Good morning, dear students. My name is Farhan Mazhar, and in this video we are working on the exercise 9D of the course book of the Pure Maths 1. And this is our second episode on this exercise. And we are going to start the work from the question number 5. He says differentiate x squared minus 3x plus 5 whole raised to power 6 with respect to x. This is the A part, and the B part, hence find the integral of the 2 into the 2x minus 3 into the x squared minus 3x plus 5 whole raised to power 5 dx. Okay. So here we have this question number 5. This expression is given x squared minus 3x plus 5 whole raised to power 6. We want to derivate it. Okay. So we will derivate it. This power will come on the side, and on this base the power will be decreased by 1. So the power will become 5. Then we will take the derivative of this base, which will be 2x minus 3 plus 0. So you can write it like this, 6, and then you can write this bracket 2x minus 3, and then you can write this expression, which is x squared minus 3x plus 5 whole raised to power 5. So this is how you will derivate. Now, they gave me, in the B part, they gave me this expression, and they asked us to integrate this. If you look at this expression and this expression, the difference is this is same, this is same. Here we have 6, here we have 2. To make this 6, what I will do, I will multiply it with the 3. So that's why I have to write 1 by 3 outside here. So 1 by 3 into 3 into 2 into this expression. So 1 by 3, and this becomes 6, and this. Now you look at this expression and this expression. They are exactly same. You know that the integration is the reverse process of the differentiation. So if the derivative of this is this, the integration of this will be this. Okay. So because this and this is same and we are integrating it, so its integration will be this. Okay. So 1 by 3 will remain outside, bracket x squared minus 3x plus 5 whole raised to power 6 plus c. So 1 by 3 will multiply with this. So 1 by 3 into x squared minus 3x plus 5 whole raised to power I write here 6. Let me stop. So so its integral will be raised to power 6. Okay. So 1 by 3 into this expression raised to power 6 plus c. 1 by 3 multiplied with this c will be also c, because c is a constant. So when it will multiply with 1 by 3, it will be another constant. So that's why I keep it as c. So the final answer is 1 by 3 bracket x squared minus 3x plus 5 bracket close raised to power 6 plus c. So this is the answer, sir, and this is how you will do the question number 5. Then we have question number 6. Let me show you the question number 6 of the exercise that we are working on is 9D from the course book of the Pure Maths 1. Question number 6. Differentiate A part under root x plus 3 whole raised to power 8 with respect to x. And the B part is hence find the integral of the under root x plus 3 raised to power 7 whole raised to power 7 divided by the under root of the x dx. Okay. So in the question number 6, this expression is given to me, and they want me to find out the derivative of this. Okay, so I will take derivative. So this power will come on the side on this expression. The power will be decreased by 1. 8 minus 1 will be 7. Then I will take the derivative of this base, because this is under root x, which means raised to power 1 by 2. So that 1 by 2 will come on the side x. So you will decrease the power by 1. So 1 by 2 minus 1, that will be minus 1 by 2, and 3's derivative is 0. Okay. So this expression is basically 1 by 2 under root x. Okay. So this 8 and 2 will be cancelled. So you are left with, bring this here, 4 by under root x into the under root x plus 3 whole raised to power 7. So this is how you will derivate this. Okay. Because then they ask us to, in the B part, they ask us to find out the integration of this. If you look at this expression and this expression, the only difference between them, it has a 4 here and it do not have 4 here. So what I will do, I will multiply with the 4, I will divide with the 4. So 1 by 4 will remain outside here, this. Because the derivative of this expression is this, so integration of this will be this. Okay. because the integration is the reverse process of the differentiation. So if the derivative of this expression is this, then the integration of this expression will be this. Okay, so this expression and this expression is same. So when you integrate this, its answer will be this, under root x plus 3 whole raised to power 8. So this 1 by 4 will remain outside and plus c with it. So just bring this 1 by 4 inside. So 1 by 4 bracket under root x plus 3 whole raised to power 8. And when 1 by 4 will multiply with the c, it will be still another constant c. So this is how you will do the question number 6, and it's a part. We are working on the exercise 9D. The topic of this chapter 9 is integration, and the topic of this exercise, which is 9D exercise, is further indefinite integration. This is the course book of the pure Maths 1. This is the maths of the Cambridge International ASA Levels Mathematics 9709. This syllabus content is related with the paper 1 of this subject. This is our second episode on this exercise. So let's move to the next. So, my dear students, now we are working on the question number 7 of the exercise 9D. Question number 7 is showing up on your screen. A part is differentiate bracket 2x under root x minus 1 bracket close whole raised to power 5 with respect to x. And the B part is hence find the integral of the 3 under root x bracket 2x under root x minus 1 bracket close whole raised to power 4 dx. Okay, so this is question number 7. In the A part, we have to differentiate it. Okay, so if you look at here, this is 2x under root x minus 1 whole raised to power 5. So we want to derivate this. This 5 will come on the side when you multiply. This is x raised to power 1. This is x raised to power 1 by 2. When you add these powers, 1 plus 1 by 2, that will be 3 by 2. So you will have 5 bracket 2 x raised to power 3 by 2 minus 1 whole raised to power 4. So 5 will come on the side and the base, and its power will be decreased by 1. 5 minus 1, that will be 4. Then I will take the derivative of this base. Okay, derivative of this base will be 2, and this power will come on the side 3 by 2, and this power will be decreased by 1. 3 by 2 minus 1, that's 1 by 2. So x raised to power 1 by 2 into 1, and minus 1's derivative is 0. Okay, this 2 and 2 will be cancelled, so you are left with the 3 x raised to power 1 by 2, which means under root x. Okay, so this 5 and 3 under root x will multiply. That will become 15 under root x. This is 2, this is x, this is under root x. Actually, I have written this x raised to power 3 by 2. You can write it like x raised to power 1 into x raised to power 1 by 2. Exactly the shape which was this. Minus 1, 2 into x under root x minus 1 raised to power 4. So this is how you will derivate this. This is question number 7, and it's A part. This is how you derivate this. Then in the B part, they asked me to find the integral of this thing. Okay, we want to integrate this. If you look at this expression and this expression, they are almost same. Under root x same. This expression is same. The only difference is here we have 15, but here we have 3. So I can make that 315. How? By multiplying with the 5. So divide with the 5 and multiply with the 5. So this will become 15 under root x bracket 2x under root x minus 1 whole raised to power 4 dx. Now this expression and this expression is same. The derivative of this expression is this. Integration of this expression will be this. Integration is the reverse process of the differentiation. So if the derivative of this expression is this, then the integration of this will be this. Okay, so this expression we have here, we want to integrate this, so its integration will be exactly this. So that's why I wrote here 2x under root x minus 1 raised to power 5 plus c. This 1 by 5 will remain outside. So you will have 2x under root x minus 1 whole raised to power 5 divided by 5 plus c. 1 by 5 multiply with the c, that will give you another constant, which is c. So this is how you will do the question number 7 and its A part. And with this question, we have completed this exercise. And we have completed exercise 9D. The topic of this exercise is further indefinite integration. This is the course book of the Pure Maths 1. Let me show you the question number, exercise 9D, question number 1, 2, 3, 4, 5, 6. There were 7 questions in this exercise. We have done in 2 episodes, we have completed this exercise. And the basic thing in this exercise is that the integration is the reverse process of the differentiation. So I hope that this video will be helpful to you. If you think that this video is helpful to you, please like this video, please comment on this video, please subscribe my channel, please share the link of this video with your other class fellows, with your cousins who are preparing AS Pure Maths 1. You see, your likes, your subscribes, your shares, your comments, they are an appreciation and a support to my work. Your appreciation and your comments are very, very important for me. My name is Farhan Mazhar and I am from Sargodha, Pakistan. So thank you very much for watching my video. Have a good day, sir. God bless you all.